Okay, hello, welcome to this session on the mean and variance of a probability generating function. So the PGF. So we've got the formulae here, which I've taken from Dr. Frost's excellent PowerPoint. E of x, the expected value of x, you would differentiate the PGF and substitute in 1. The variance would be the second differential with 1 substituted in, plus the first differential there with 1 substituted in. Then take away the square of 1 substituted into the first differential. So it really is as simple as that. Now, so these formulae are really fundamental. Here's a bit of an exam style question, which we're going to go through in steps. Okay, so we're going to find K, a really common style of question here. Let's use the fact that if I substitute in 1 into the PGF, out comes 1. So here 1 would equal K lots of 4 times 1 plus 1 squared plus 1 cubed all squared. So 1 equals K lots of, well, we've got 4 plus 1, that's 6. 6 squared is 36. So K is 1/36. Okay, so we've done part A. Do part B. Let's rewrite this. So K is 1/36. I'm just going to expand that big bracket there. So how many t squares we've got, etc. So we've got 16 t squared plus 8 t cubed plus 9 t to the 4 plus 2 t to the 5 and just 1 t to the power 6. Now if I write all that out, I get 16/36, 4/9. I've got 4/9 t squared plus 8/36. 8/36 is 2/9 t cubed. 9/36 is a quarter, t to the power 4. 2/36, that's 1/18, t to the power 5, plus 1/36, t6. And I can really see here what the probability of any of them are, but we want the probability of 4. So I'll look at what the coefficient is of t to the power 4, and it's a quarter. So there we go. Job done. Okay, so we're going to now do part C and part D. So we now know, well, g of x, we've got kind of a fuller version of it, 4/9 t squared plus 2/9 t cubed plus a quarter t to the power 4 plus 1/18 t to the power 5 plus 1/36 t to the power 6. Now you need the differential of this, the first and the second, for the next two parts. So g dash x, let's just differentiate each bit. So 8/9 t, it's just a polynomial, we can all differentiate this. 3 over 9 is, of course, 2/3 t squared plus t to the power 3, 4 over 4 in front of that, plus 5/18 t to the power 4 plus 6 over 36, 1/6 t to the power 5. Now, g double dash of t, the second differential, you've got 8 over 9 plus 4/3 t plus 3t squared plus 20 over 18, 10/9 t cubed plus 5/6 t to the power 4. So, well, what's the expected value of x? Well, that is, of course, g dash x of 1. Now, if we substitute 1 into this one, the second line, there we go. We've got 8 over 9 plus 2 over 3 plus 1 plus 5 over 18 plus 1 over 6. We actually get a bit of a treat. It's a nice value, which is 3. The variance of x would be, well, remember, it's going to be the second differential with 1 substituted plus the first differential with 1 substituted in minus the expected value squared. The first differential with 1 substituted in, then squared. Right, so we've got 43 over 6 plus 3 minus 3 squared. I'll stick that in the calculator and you get 7 over 6. So that should be 3 and that should be 7 over 6. So we've worked through all the parts there. This is just an example I've made up. Well, I've adapted it from one I've seen in the sample paper. And I hope the steps make sense. Please go over it carefully and good luck.